I wanted to share with you some thoughts on 3D printing and my experience. A lot of times people will ask me, what printer should I buy? And gosh, that's a hard question to answer. So what I want to do is put together some information that we've learned over probably the last 5-6 years and share with you really what my experience and what my opinions are, provide some tips and some of the pros and cons of each printer. Compare the ease of use on a scale of 1 to 3, and also the price and the operating expense, because sometimes people don't realize there's an operating expense. There's the resin, there's the tanks, and that's not even including really the time that's going to go into training someone and training yourself as well. And that's something I recommend, is that doctor learn first and then share it with everyone else, and then delegate as more and more people become trained. But a lot of this, once the doctor figures it out, or if you have a tech that figures it out, make sure they teach you, it's really pretty easy. This is our 3D print lab currently. We started upstairs with just our EnvisionTEC printer, and then have grown. You don't need all these printers, but a lot of times we're doing some testing on printers. Sometimes it's just my own curiosity, how a printer will work and what kind of resin. So you don't need all of these, but these are the ones that I will share with you what I know. And then you're also going to have to consider post-processing, because once you print, you're then going to have to process that model. And we'll talk a little bit more about that. Again, you don't need all of these. Some of these are redundant systems, like all 3 of these things do the exact same thing. And these do the same thing too. It's just different techniques, and I'll share all of that with you. Now, in my satellite location, we do it super simple. This is a back storage closet. I just opened the door for ventilation, and these are photon printers, which right now are about $200 a piece. And then we do the post-processing in a corner of our sterilization lab, using actually even an old triad machine that I had in storage from years ago when I used to use triad material. So you can do it small scale, you can do it large scale. That's what I really think is exciting. So what I'm going to do is share with you what I know about these printers. There's other printers that are out there. We started with an EnvisionTEC Vida because really that was the first available into the ortho market, and we had an early machine there, and we've had that for quite a few years, and it's great. We then slowly added to a MoonRay, a SprintRay. We did Form 2. We had several Form 2s for quite a while. Form 3, the EPACs, the Photon, these are all a lower price printer that performs well, and we use all of those. So there's not only different printers, there's also different resins. So this is kind of a combination. We just pulled the different printers, different resins. So I encourage people, once you find the printer you want, find the resin you like, and we'll talk about calibration, how you can get the accuracy and the resolution that you want. Sometimes people get confused when they start using different types of resins, not realizing that each one can be a little bit different. I try to explain it to people from an analog standpoint. It's kind of like when you switch impression materials. There's a little bit, it's a little different. They all work, but there might be some little differences between them. Now, for people who are watching this or new in printing, what I want to do is just kind of share what the difference is. Fused deposition modeling is one type of 3D printer. You may be more, it's the kind that lays material down, not really used a whole lot in our clinic. Stratus is an example of that. A lot of times I think of kids using those as they're building models. There's also stereolithography, which is, you'll see abbreviated as SLA type printing, and it uses a laser as its light source. And then there's direct light processing, or sometimes you'll see it as digital light processing, and it can use like a type of light source like a projector, or also an LED or LCD screen. So we'll look at some examples. So fused deposition modeling, Objet uses a polyjet. I always think of like a mini glue gun, and that mini glue each layer. So as it's laying down those layers of that molten plastic, it then has to fuse back together. So this is really what you're looking at, but obviously on a very, very small scale when you think about how the size of those layers that are being laid down. So that's kind of a nice picture of what fused deposition modeling looks like. Then if you're talking about something like a Formlab printer, a 2 or 3, it's an SLA printer and it's using a laser. So you've got this source of a laser, it reflects off of a mirror, and then it goes up into your vat. Now, it will outline the object and then color it in. That's why if you're comparing the speed of printers, an SLA printer may take one length of time to do one object, but if you put another object on that same print platform, it slows it down because it has to outline each, color it in, outline the next, and color it in. So SLA printers tend to take longer when you're doing multiple print job or multiple objects in the same print job. Look at DLP, and EnvisionTEC is a DLP, MoonRay's and SprintRay's, and they're using a projected light source. And what happens, because it's a projected light source, it's exposing the whole layer. Now, LED or LCD also work exposing an entire layer, but they're using a different source of light instead of just that one projected light. If you look inside, you'll see a bunch of little lights like an LCD or an LED screen. Expose the entire layer at the same time. And so the print time really has to do with the number of layers that is being exposed. So if you put one model or you put 5 models, if they're all the same height, it doesn't change the time because it's really just the number of layers that it has to lay down. So that's why DLP printing is faster. Now, regardless of the light source, if it's SLA or DLP, they really kind of work the same because they're going to take that liquid photopolymer, which is called kind of our goo, and in there, there's a photo initiator that's going to absorb that light. Either it comes from a laser, it comes from a projector, it comes from an LED source, and then it creates that polymerization. So you're basically taking a liquid to a solid using a photo initiator, similar to like when we cure composite. And so what happens is there's exposure. You've got that your resin. That exposure pattern then hardens that resin and it has to stick to that build platform. That build platform then needs to separate from what we call the vat, where that liquid is held. And so the surface of that vat has different types of material on there that will allow it to basically non-stick. Reminds me of kind of your cookie sheet, the non-stick type cookie sheet. Usually it's a plastic, a clear plastic, because remember the light has to penetrate through it. Then the build platform has to raise up enough, or this part, the vat, has to separate to now create just enough physical barrier or physical opening so that new resin can run underneath, the light can go off again, it adds another layer, and then the build platform and vat have to separate. So in 3D printing, there's a chemical component, which is the photo curing, and there's also the mechanical component of any printer that is the up and down of that build platform. And that's really the Z. You'll hear people talking about the capability of what layers or how small a layer or what the Z performs. That is the Z axis. So you're thinking in 3 planes of space. You've got your X and Y, and then this is really a component of the Z, is the mechanical lifting of that plate. Now what happens is once that layer is exposed and separates, there's a green state. So you've got your completely exposed layer. Then you're going to have an area what's called a semi-reactive green state, because when the light source goes off, this new resin has to be able to cure and adhere to the other. So again, it's kind of like when you're curing a composite, you've got some uncured material, and so that it's really that green state is something when you're finished, the last layer will have that stickiness, and that's why you have to post-process it, because you're done printing and you have to get the rest of the layer off. Now, if you're going to print in-house, it's different than when we're ready to hit send before, because when you hit send, what's happening behind the scenes is there's the processing of that scan to be able to print it or to be able to manipulate it and use it for other applications. One thing I encourage people when you're going to go in-house, if you get frustrated at first, like, man, this isn't working, go back and look at your scans. Make sure who's ever scanning for you is getting really good scans and isn't just letting the autofill take over. You know, sometimes people show me scans and it almost reminds me of extreme Photoshop. Yeah, it looks really good on the screen, but if you really take a look at the scan, a lot of it has been autofilled in. So once you get in-house, you can use those, those digital models as records. You're not going to have to do anything. But if you want to start to print, there's some basic things you can do, models and retainers. And a lot of it you can do with some basic software and freeware that's out there. Or your printer may even have enough software included that'll let you repair, let you base, let you label. It's only when you start getting to some of the advanced applications like indirect bonding, custom aligner systems, that you're probably going to have to invest in some software or maybe outsource the design part and then do the printing yourself. So there's a lot of things that you buy yourself a printer, you figure out how the printer works, and all of a sudden you can start doing a lot of these things and not even invest in any software yet. So those decisions are, what do you want to print? Do you just want to do it with models, aligners, indirect bond trays, splints? You always tell people, start here. This is super easy. You'll be surprised. You can teach yourself this in an afternoon, and then start moving into some of these more complicated areas. How much are you going to print? I know people that run their entire operation off of very small and inexpensive printers. There's people that have multiple larger platform printers. So it kind of depends, if you're going to start small and ramp up or really what you're going to want to do. Who's going to do the printing for you? Are you going to have a dedicated staff person? Are you going to do it? When are you going to print? Where will you print? These are things people sometimes get frustrated with. They don't have a dedicated person. They expect someone who's already maybe seeing patients. Okay, they're going to print too. If you have a dedicated lab, that's great. But if not, you're going to need to figure these things out. They seem really simple, but if you don't think that through, you'll get very frustrated. Consider the price of the resin that you're going to be putting into your printers, because the printer price really doesn't matter after a while. I mean, I was surprised when I looked, a Formlabs printer, and 1 year, we ran $10,000 worth of printing of resin through some of our Formlabs, and I'm thinking, well, that was way more than what we even paid for the printer itself. And then consider what resins can be used. Now, some printers have proprietary resins that they're really made just to use their type of resin that they manufacture, that they either sell to you or they sell through a distributor. And those are really closed systems. And then there's some systems that are completely open. You can use anything that you can buy. And that's particularly true if you're just creating models. Now, when you're going to indirect bonding trays and splints, things that are going to be in people's mouths, you do have to use biocompatible, resins that are approved to be put in somebody's mouth. But open source resin for models is kind of like when you're buying stone or gypsum, to pour up your models. There's a lot of different brands. They all seem a little bit different. Maybe they all needed a little bit of different, ratio of water to powder. Same thing with your open source resins. So let me go first with our Vida. That's our far most expensive one, and they're probably at the time we bought range. So it's very accurate, it's very reliable, and it's fast, but it has the highest printer cost of any of those you saw on our screen. Now there's more expensive ones too that you could invest in, but again, I'm just talking about my experience. The software is not hard, but it's not the easiest. It just doesn't look as pretty as some of the other, but it's not difficult to use. Now the consumables, the tanks, what people fail to realize is that resin sits in a tank, and that tank will go bad, particularly that bottom layer, which is that important layer that's going to allow your cured material to separate, the build platform to lift up. That goes bad. Those tanks themselves can run about $500, and you can get a rebate from some people if you send the old tank in. You get a little bit of money off of them. Now also their resin is a closed source, and when their resin comes, there's a little ID tag that you have to put in the back of the machine that allows you to print. So it's a very closed system. If you don't have the tag, it won't let you. I don't know any way to work around that. And sometimes we'd run into the tag would say, oh, there's no more resin in that bottle, but actually there was. So it's very accurate, it's fast, but it can be an investment. And what can we print? You know, we can print retainers, we can print appliances, we print aligner models. We can't direct print aligners yet. I know there are people who are talking about how they do that or how that's coming with different printers. And we can print indirect bonding trays on there. Quite honestly, right now in our lab, this is the least used. It used to be used a lot. The problem is when you have an expensive printer and expensive parts, sometimes we're looking at, oh, we bought 2 resin bottles for this, bought another printer, one of the cheaper ones, and people were afraid of it. When I have one staff member, this is her baby. If other people start to touch it, she starts to get the jitters. So people tend to stay away from that. No one wants to be responsible for breaking the Vida, where some of the other ones people just don't, you know, it's not they don't care, but they're not as nervous around them. We buy our printing resin from 365 Printing, and we like to use the Ortho Tough. There's other types that are out there, but we found that we've calibrated to Ortho Tough. When you find one you like, stay with it. And also buy an extra tank. Keep one of those tanks handy, because if that tank goes, you can't use the printer. So always keep a spare. Now we'll talk about our MoonRay. So after we had our EnvisionTEC, we then went and had a Formlabs printer and also MoonRay printer. So we've had our original MoonRay for quite a few years. Haven't had any issues with it as far as repair. So, and then our SprintRay 2, we're probably going on about a year. We had one of the first ones that were available. Both of these are really reliable. We use both of those every day in our clinic, or in our, you know, obviously for our clinic in our print lab. They're both accurate, reliable. The speed, they're very, you know, they're fast. When you start talking about speed, part of it has to do with what you're printing, how you're printing it, what layers you're printing at, and you know, these all compare to really that EnvisionTEC machine, although some will claim it's EnvisionTEC's a little bit faster, but you can make all of them a little faster by, excuse me, how you change different things up. Cost, obviously much less than the EnvisionTEC machine. And actually, I just saw online there's a really good deal on MoonRays now, and we really like, what we use our MoonRay for is our indirect bonding trays now, and I'll talk about that in a little bit. The one thing now to run the software is very user-friendly, but there's a basic plan that comes with the machines. We have updated. There's also a premium plan and then a pro plan. Obviously not a huge investment, but when you go with the pro plan, there's other things that will help. You can monitor the resin usage and history, and a lot of it is available. So look at the plans you want. Some of the difference is with a SprintRay or a MoonRay, it's a closed and open source. If you just have the basic free plan, it's going to have all of the parameters based for a SprintRay resin. So what happens when you tell it what kind of resin it's going to do, you're going to use, it's going to go ahead and adjust the printer for that resin. Now, if you want to use open source, you want to buy buy different materials, you're going to need to go with a pro plan, because there's selected third-party resins that you can use. You can see when you look at this, there's advanced scan repair. So you're going to be able to repair some of your scans here. So see which one matches you best. A lot of times we'll just go with this one because we're going to want these features that exist there, and it's not a huge. The thing with the MoonRay, it does have a smaller print platform. It's very easy to use. The tanks are consumable, so you're going to go through tanks, but they're less expensive than, say, your EnvisionTEC. And you can even on a MoonRay change just the film alone, which even takes the price down even more. Again, I mentioned it's closed and open, so if you get that pro plan, you can have a lot of different sources, so you can control that resin expense. Things that we print on the MoonRay and SprintRay, we do retainers, we do models for appliances, we do models for aligners, and then we do our indirect bonding trays. We like to use the NextDent resin. SprintRay has a resin also, but we have our machines calibrated and our software calibrated for the NextDent resin. And predominantly we'll use the MoonRay for that. Part of it, what will help extend the lives of your tank is if you're not switching resins. So a lot of times we'll tell people or have different machines dedicated to different types of print jobs. The MoonRay, we just always keep it loaded with the next step resin. We print them horizontally. This way, everything is pre-set up. All you have to do is hit print. You don't have to worry what resin is in there, because if you're trying to swap things back and forth, sometimes it can get confusing for staff. Like, oh man, I forgot to change that this was model resin, not indirect bond resin. The nice thing is too, is this is a smaller vat, so you have less material in there than like the SprintRay, because each of these trays takes 6 or 8 milliliters. So you only want to dump a couple hundred in, because if you can keep it in there, it can reheat. Where the SprintRay has a 500 milliliters, which is great if you're doing big model jobs, but for these small arches, it's going to take a long time before you go through that material. So some of it's just going to be used over and over again. Now, when we use our MoonRay for our indirect bond trays, we'll go up 50 microns and they print in about an hour. If you go 100 microns, it'll be closer to about maybe 38, 40 minutes. They won't be quite as clear, but it definitely is an option. And usually we can fit 4 to 5 trays. Usually we'll just go 4, so it's like 2 patients if we're doing upper and lower, just to kind of help keep things organized. And you can just peel them off and then keep going. I do have a little tutorial on post-processing indirect bonding trays. One tip that we found when we were trying to run both the SprintRay and the MoonRay, and I'm not sure if this is still true or not, but we were running into some issues where it would kind of almost get confused and would shut one printer off. So we almost had to make sure they were running on 2 different networks. So the easiest way to run your MoonRay is there's a direct connect MoonRay network. It's kind of like your wireless printer, where you just hit print and it goes from your computer. I like you running the MoonRay off of its own network, and then it doesn't interfere with the SprintRay at all. So they may have fixed that by now. Some people say they don't have an issue. For some reason, we just didn't. We had them both on the network, hardwired. And it could have just been our setup. But if for some reason, both the MoonRay and SprintRay, if you go to print something and my staff will say, I can't find the printer, it's just going to have to reset it. Just shut it down, or just turn it off, turn it back on, and we'll find it. A lot of it reminds me again too, like sometimes your printer, your regular document printers will do that. You just can't find it, and then you turn it on, turn it back on. The other thing you have to be cautious about MoonRays is that tell your staff you always have to take this part off the platform before you take the tank off. Because what's kind of crazy is when you take that tank off, there's the guts of your printer, which is fascinating when you look inside, but kind of scary if you ever have anything drip into it. So always remove the platform before you'd remove the tank. And I laugh because we've done that before. You sometimes will have to replace tanks. Now you can buy the entire tank assembly and pull it off, or the nice thing is you can just replace this part that has the plastic. It's 4 little screws. You take them out, you put a new drum on, and you're good to go. So we tend to replace the drums more because this metal part doesn't go bad. It just slides back and forth. And again, always keep some extras. If you invest an extra $100 and make sure if you use that one, just have a protocol that you order the next. So you might not need it for 6, 8 months or a year from now, but at least you'll have it instead of trying to find it. So simple process there. The one thing we found that was kind of annoying, and it was particularly because of, I think, the indirect bond resin. It has a lot of volatile organic compounds that are released, so it's kind of enclosed in that tank, and those little black handles would get sticky, even if your hands were clean, and then shortly after they became sticky, we would know they would snap right about here, and we'd just order a new one, and there's about $100 probably to do that. And then I had a drawer of them, and I thought, this is crazy. I'm not ordering another one. So what we did is I figured out how to fix it, and I like to share this because you go to your hardware store, and this is what you need. You need a hex nut, and you also need a shaft collar that has a set screw. And you can see there's a little set screw inside there. That's the set screw right there. So you just unscrew the broken handle. If there's any part left, just take it off. And then I just even did a little video and see if it'll work. So what you're going to do is put that hex nut on, and I'll show you where you need to put it because then the shaft is going to need to touch it. Then go ahead and you're going to screw that, because this was the part that was left from your broken handle. You just took the black part off, screw it in, and then you need to leave that, get that hex nut to a place that that shaft collar can go onto it and tighten it in. So you sometimes have to fool around with where you want it so you get enough height. Super easy fix, and then you never have to buy a new one, and it doesn't get sticky. Yep, so there you go. And then yep, that's it. The other thing that we found with our MoonRay printers is to lift them up, you had to compress the top to slide it up. And we started to see just little crazy, like cracking lines there. Plus you're trying to get it up, you've got to take your gloves off. So we just added some handles, probably about a year and a half ago. And this has made it so much easier just to pick it straight up. All we did, again, we went to our favorite hardware store, went to Menards, found a cabinet handle that had a large back plate on it. Just that way we used some Gorilla mounting tape, which is clear, put a piece of mounting tape, stuck the handle on. Now we can really easily lift it off, and it avoids any sticky lids or any of those corners. Now, if there's SprintRay, we're currently using this version. Haven't tried the beta version yet, so I can't really comment on that. The software that runs both the MoonRay and SprintRay are very easy to use as well. We like to use the SprintRay die and model tan in our SprintRay Pro, and then we do print our models at 100 microns, and we like to go horizontal without supports, either with both the horseshoe or base models. You'll see a lot of people printing vertical, and you can do that. One, I think it's harder to figure out the orientation. You have much more success if you go flat. A lot of labs will still go flat. And when you're looking at the time, if you're going flat, it may take one time. If you take that same model and stand it up, remember it's based on on layers. So it may take a lot longer to print horizontally, but you can have much more. So really at the end of the day, flat or horizontal, the end of the day, you're going to end up with the same amount of models. It's just the number of print jobs you run. And honestly, I'd rather have a print job fail with 6 models on it than 15 models on it, because print jobs do fail. Do they fail often after you get the hang of it? No, but they can. And I'll explain to you what's some things to look for that sometimes people don't realize affect if their print job is going to be successful. Now for us, a lot of our aligner models are already pre-labeled with the name and 3 shape. If they're not, if you just pop these on supports, the printer will label them for you, which is really nice. Keep in mind, though, it's going to label them what the file name is. So always put the patient's name as part of the file name. So when it uses that file name, it will have the patient's identification on there. There's also ways that you can go into something like 3D Builder and emboss them. And when you emboss it, then you can add it yourself too. I do have a little tutorial on how, if you want to put your logo on your models, how it's easy to do with 3D Builder if you're going to be using for something promotional. It does have a larger platform than the MoonRay, so you can get quite a few models on there. Usually we can run about, if we're going horseshoes, maybe 8, 10. If they're based models, obviously less. And we repeatedly run that throughout the day. So both SprintRay and MoonRay are going all day. I think a good investment is the premium care plan. That's if you ever need to hot swap them. Hot swap means you call and say, oh my gosh, I broke my printer, or it broke itself. What should I do? That way they will send you a new one, or a loaner while they fix yours. Formlabs does the same thing. So we've used that several times where maybe we had a resin spill, and they will send us one, and then we will go ahead and send back that one. So hot swapping is really a good investment because you don't want to be down a printer. We did the same thing with adding a handle to our SprintRay by using that same cabinet handle, using our Gorilla mounting tape, and it does have a little latch underneath you can catch on to, but this is so much easier to wipe off if somebody gets sticky hands on on it. It's harder to get that resin off of the acrylic. Now with your SprintRay Pro, you're going to have to replace the whole tank, and those tanks are a little bit more than the MoonRay. Do they fail? Yeah, they do. We tend to use the same resins, so we're not fooling with that tank a lot. I think people who switch resins, like they have one tank and they're going to run print job, then oh, I need a different type of resin, and they're going to just have to pour it out, clean the tank. I think that's harder on tanks, so always have an extra. I like to have one tank per resin type, so we're not swapping back and forth a lot. And then you want to have an extra, because a lot of times it'll fail and you don't realize it's going to fail until it does. Be careful when you're removing failed print jobs. If anything gets stuck to that layer underneath, don't stick a spatula or something in there to peel it up, because you can tear that little plastic liner. You know, I like to use my fingers to get it up, or pour out the extra resin, put a little bit of IPA in there and let it soak. Again, it kind of reminds me when you're trying to clean your dishes and you got something burnt on the bottom of your pan, you let it soak a little bit and then it peels right up instead of trying to pry it off. The one thing we found that, you know, you're going to have to stir that resin some. You'll see it maybe settle out, like maybe over a weekend. It's kind of like when you open a paint can that's been colored and you can kind of see the swirly colors. You're going to want to agitate that. You know, if it's still in the bottle, just agitate that on like a orbital shaker, or just shake it around. If it's already in the vat, what I like to do is I like to use this spatula. There's one that comes with the printer, but it's really short and I think it's really stiff. I love these ones from Dollar Tree, so obviously they're $1. They're just a perfect angle. They're super soft, so I don't have to worry about scraping my tank, and they've got a nice long handle so my hands aren't too close to that resin. So those are a good buy from the Dollar Tree. There's also a SprintRay dental user group. I really encourage people, when you're going to start to print, get on some of these printing groups, not only the dental ones, but the non-dental ones. If there's a certain printer you like, do the dental one and then also kind of the non-dental user. I learned so much about 3D printing from people who are printing miniatures, you know, like their Dungeons and Dragons miniatures or a different type of hobbyists, because they're actually trying to print things that are a lot harder than what we're trying to print. So they've got a lot more knowledge base on getting fine details, even finer than what we're looking for. Now we'll talk about Formlabs. We've had several forms, Form 2. They're a great printer. They're super easy to use. That's why we've set up a couple schools with them. We've set up my kids' school with them. The software is very intuitive, and there's parts that will stop you, that won't let you print if it's going to fail. So that's kind of nice. And then the updated versions of Form 3. So we've got a lot of experience. They're accurate and they're reliable. They're very reliable. Are they slow? Yeah, they can be, particularly when you put multiple print jobs, because remember, you're going to do one and it's going to color, you know, it's going to have to outline multiples. But these are really great, particularly for overnight, print jobs that you don't care it's going to take 4 or 5 hours. We'll load that up, leave it print at night. The nice thing too about a Formlabs printer is that you'll see that there's the resin cartridge in the back, and it will continually load for you. So as long as there's enough resin in this tank, it will keep loading for your print jobs. And for us, we're doing short stuff, but people who are doing maybe models horizontal or vertically, or people who are doing different objects that are really tall, may take up a lot of resin, more resin that would fit in a tank. And some of the other printers, we have to manually add it. This one here will auto feed for you, so that's really nice. So, like I said, the software is really easy to use. You can teach anyone to use this really quick. The one thing that's really nice, it has a leveling feature, and if your printer's not level, it won't let you print. It'll say go back and make sure this printer is level, and I'll talk about that later, because a lot of printers don't have that feature. And if you try to print with a printer that's not level, you will lose print jobs. And it's a feature, it's a thing that people tend to forget about, or maybe don't realize that can make a huge difference. The other thing too, it does have an automatic wiper, so it's stirring that resin for you as it's printing. So there's just a typical model that came off of a Formlabs. What was fun is we print the same person like over and over again. And so we've got a whole box of different resins, different printers, and we can try them on and see how we like the fits. They all fit. They will all fit a little bit different, and we'll talk about calibration later. The nice thing about with our Formlabs printer is you can keep track of by printer. It'll tell you different statistics on how many prints you've done. This is one of our new ones. You can see we've done 108 print jobs. We were 94% successful. How many liters we've used. This keeps track even over time. Like 100 and some in this one. Shows you what you got out of them. So it's really kind of interesting and fascinating to look at how much you've used, how many print jobs you've done, and what your material is. This is their updated software, and again, it's nice. It gives you a lot of the details. You can see how long that print job would take, but it's also, you can see I get the thumbs down. This is unprintable. It's saying, boy, it doesn't like this. You can see where it's showing red is where those are unsupported. You don't have enough supports there, and I obviously wouldn't have tried to print that splint that way, but I thought it was kind of fun to show it. It'll tell you then too what type of material. So it is a closed source printer, and there are ways that you can go open source, but it is closed source because you buy the tanks from them. When you stick the tank in, there's a chip, and that's the chip that then will record everything that's printed off of that tank. So it's closed. There is a way to do open. I'll talk about it a little bit later. You can see real close. If you don't have a name on the model, if you go ahead and put it on supports, though, it will, whatever that file name is. So if you put the patient's name in there, that patient's name would show up. Also, if you can edit supports, like, man, I want to get rid of some of these supports. It's really good at showing you the red areas, like, okay, these are the areas that are unsupported. And sometimes you may find, even on models with teeth in different position, you may need to go in and remove a support so that it doesn't end up printing on, like, on the facial surface. So their software is really easy to manipulate. You will have to replace tanks. These two tanks go off of the Form 2. This was the original one that they sold, and then this one has an extended life on it. Because we're not swapping resins a lot, we do get quite a few print jobs off of one of them. So I'm not saying we never replace them, but not quite as often as they're going to tell you on the website that you're going to need to. And then to our Form 3 tank, a little bit more in price, but I'll knock on wood, I don't know that we've replaced it yet, and we've had that printer for maybe a year, right when they first came out. I can't remember how long that is, maybe a little bit longer. So I know we did go through one tank. So yes, you're going to have to replace those tanks. How you can tell, what's nice with the Formlab, you can tell when the tank's getting old. I've never had one like rupture, like on my SprintRay, but what you'll see is you'll start to see, like, your models won't be as defined, or they'll almost be like, I would say like a smeariness to it, like, whoa, the teeth aren't as defined as they used to be. And if you look at the bottom of the tank, you'll notice it starts to get cloudy, or it'll say ghosting. And the new software too will show you where you're getting that ghosting, where, if you're always putting a model in a certain place, that part starts to get a little bit worn out. So it is possible to know when it's going to happen and when you're going to need a new tank. Now, if you print on supports, which sometimes we'll do if they're not labeled, so we know who that person is, there's a lot of resin, and Formlabs resin's a little bit thicker, so it doesn't run off the plate. So we just made a homemade tank drip. Save a lid. That's the lid that comes with your new tank. We cut a hole in it, put these little L supports from the hardware store, and then we'll just flip it and let all that resin drain back into the tank before we take it off. It's just a little less messy, saves on resin. They also too have a users group, which I encourage people to get on. I've learned so much on all of these different, you can see how many different resin groups I like to look at. This is a nice group too. Even though I don't own one of those printers, I like to see what they're doing. Now it takes us to ePacks, and ePacks are a low price printer. If you're looking, if you're comparing, the EnvisionTEC, you were looking in the 20s. SprintRay's around 8. Now the MoonRays are about 2. Formlab is probably about 3,200. EPAX, and EPAX 1 is probably about 500 now, and then the EPAX 10 is around 1,100. So these are obviously a lot less. There's some advantages and there's some disadvantages too. A lot of times people, if they're just getting in, will start with something cheap because you're thinking, shoot, if I break it, or if I can't figure this out, or I hate it, I'm only $500 in. And there's a lot of things you can do. They are reliable and accurate. The reason I took part of the smiley face off here is there's certain things that you have to do and dial in some of your own settings. When people say these aren't accurate, the problem is they don't have the settings set right. Unlike your other more sophisticated, or I should say more expensive printers too, when you tell it, okay, I'm using my model die tan, it's going to set exposures for you. Here, you're going to have to tell it what you're using and what you want those exposures to be, which can be kind of fun because you can start fooling around with your exposure time and you can get some of these printers to be really fast because you're cutting a second here or there, where the other printers, you really can't change some of those parameters. They've determined what's best for you, and that's nice because it's easy, but this can be a lot of fun too. They're obviously very inexpensive. The print platform on our EPAX 10 is bigger than our SprintRay platform. So the EPAX 10 now is our biggest print platform. So it's bigger maybe by an inch, inch and a half. And now the software, the operating software, I think is easy to use, particularly once you know the parameters. It's free software. You can run these off of different softwares. I'll show you the one that we like to use, but these came off of our EPAX 10. They're both very quick printers, and I like the EPAX then to do indirect bonding trays, and I have friends that do all their indirect bonding trays just off of an EPAX 1. The EPAX 10, I think this tank is too big. I wouldn't want to fill it with that much resin to start. But the nice thing is you can dump just about any type of resin in these machines and get it to work. And I'll show you a little bit more about that. This one here is what's called a skin colored by Photon. Photon also makes another low price printer. It's super cheap. You a lot of times can get it for under $30 a liter versus, maybe $2.99 for an EnvisionTEC, $149 for SprintRay, MoonRay, $149 for Formlabs. So the resin's a lot less. This is a soy-based that works really well in an EPAX 10. Again, it's made by AnyCubic Photon. It's about $50 a liter, and it is soy-based. Supposedly it's compostable. I'm not so sure on that yet. We've had some buried for a while, and it's not like what I'm thinking composting means. So we're still kind of working on how do you actually biodegrade those, because they're supposed to be. Now the nice thing too, particularly if you're getting started, in EPAX 1, remember the tank or the vat where you poured everything in. If you needed complete new vat there, or want to have extras, which we do to swap out resins quickly, they're $69. You can also just replace the film. When you flip it over, there's a bunch of screws, and you can get a pack of those film for $23. And I just pulled this off their website not long ago. So it's kind of a cheap way to get started. If you need an EPAX 10, it has a big platform. You're going to look at about $129 for a tank, and one film is about $23. So if you have a tank that goes bad, we just swap out the film, and it's just a bunch of screws. It's nothing too. Resin sources, again, a lot of open source resins. I should have waited. Here's the AnyCubic. That was $42. I think that one I got off of Amazon there. Usually we'll use the peach, but you can use any of these colors. I just don't like these because they're kind of ugly when you print, but we'll use those for fun projects. And then the soy-based resin I like in both of these printers. The EPAX 10, there's certain resins. EPAX has a soy-based resin that works. They have some of their own resins. I think they're a little bit more brittle than the AnyCubic soy. And for some reason on the 10, it doesn't seem to like the skin color as well. We were having some print jobs fail, and we just didn't feel like screwing around with the parameters anymore. So we just always use this or one of these colors. The nice thing is too, if you start to run out of one color and we have others, we just keep dumping them in. So we get some weird colors every once in a while. But this soy-based resin has a really large range of exposure, and I swear you can expose it with a flashlight. It doesn't seem to be too sensitive. As long as it's a pigmented resin, it'll keep going. You don't have to keep swapping it out. The software that we use right now is Chitubox, and that's really what kind of comes with it, or download comes. It's a free software. Some people will use something called Lychee Slicer. Again, that one is, I think that one is free as well. It may be like a $10, $12 type deal. It's not a huge investment. The only thing, and this you can see, we could have gotten even more. We can get about 10 to maybe 12 horseshoes on the EPAX 10. EPAX 1 has a real small print platform. You could probably get, if I have a base model, I'll do 2. Indirect bond trays, I can get 4. So horseshoes, you could get about 4 in there as well. The thing about this is once you get it on that print platform, it really moves around pretty easy. So once you learn the basic manipulation, they have the coolest hollow and drill hole function, I think, of any of them. It's really pretty much automatic. Over on this side, there's a lot of different settings you can play with, but here's the big difference when you're trying to use low-cost printers, is you're going to have to go over into settings. And the settings, one, you're going to have to tell it what type of printer you're using. You set those defaults in there. And then, so you pick the machine to make sure that you're going to end up with the right platform size. And then you go ahead and you tell it what you're basically printing. So our models, we do the photon resin at 100 microns, and this bottom layer is how many layers are going to be on the bottom, basically are going to make it stick to that print platform. How long am I going to expose them? Those bottom layers are usually exposed longer. This you could take down probably even to 40. We've been playing with some of these. So you've got how many layers you're going to have and how many of those longer exposed layers to get it to stick. And then you're going to go ahead and the normal exposure time for each layer. And a lot of times people drop that down even to 8. And then there's the off time. So if you imagine it has to be exposed, the light has to turn off. And this is true for all printers. That platform has to raise up. The liquid has to run underneath the platform. The platform has to drop. And the light needs to turn back on. So the only difference for these cheaper printers is you've got to figure these out. Most of them are available online. A lot of them are available from the resin manufacturers. And then you can tweak them too and try to see. A friend of mine, one day we were trying to see who could get a model the fastest off of one of these printers. So we kept dropping these down and dropping them down. And we got them down really a lot lower. So you can have some fun with that. And up here, that went closer up there. That was just actually, we were printing some mask frames yesterday, and that's what Patty was doing those at, and they were all very, successful. So it's kind of a fun software. And again, if you go online and go like to YouTube, there's some really nice tutorials on Chitubox because a lot of hobbyists use this, and they do some super fancy things with it. So on both of those, we print retainers, appliances, models for aligners, the indirect bonding trays. So I just like that one for, again, this one's a little bit smaller. Oh, here you can see, how many we could get on that large X10 platform. So all printers work. I recommend if you get one or take a look at someone who's printing one and just really look at the difference in the model. So here, one thing this is off of Thingiverse by Dr. Ferguson. This is actually a 3D object you can print that helps drain the platform of your X10. So those are helpful. Imagine when you have a platform that big, when it raises up, there's a lot of resin just sitting on there, and you want to drain it off, one, to eliminate the mess. And there's a nice EPAX dental user group. There's one that's the printer. People just own the printer and are printing all kind of different things on it. So you can. So the X1, which is the smallest one, they're very fast. They're super cheap, but they do have a sprint platform. I know people just buy this and buy multiples of these. They may have 5 or 6 of them, so they still have a really high capacity just running different print jobs. And it's kind of nice. I always tell people, no matter what you get, say if you get a EnvisionTEC or you get a SprintRay, also get yourself a cheaper backup. We had one, we were doing some testing for a company, and it really took out a couple printers, and they're like, what are you going to use tonight? And I'm like, okay, I got the ePax because it runs off of a memory stick. You can hardwire it, but you can just load stuff off of a flash drive. So you can be sitting at any computer, load it up, same with the X10, and just put the flash drive in and go. So if your network goes down or you have some other issues, sometimes we have to jump in and rely solely on the cheap ones. Again, tanks. The tanks are really durable. I was surprised for the price. And when you do have to change them a little bit, they're not very expensive. Again, the open resin source is fun. But find the resin you like and keep playing with it. Don't keep trying to try different ones. You can, but you're going to have to mess around with some of those settings a little bit. We like the one that has a bunch of different colors because then it makes it less boring. Here's our indirect bond trays coming off of a NextDent printer. They tend to print NextDent resin really nice. The X10, obviously you can get a lot more on it. There's just certain resins that we've had a hard time getting it to completely adhere to the platform, but we know for sure this AnyCubic soy does, and it's one of the cheapest ones we've found, so we're happy with that. Plus it doesn't quite smell as much. Now I'd like to share what we know about a photon. They're very inexpensive. They're about under $200. And yes, you can actually use them for dentistry. If you want to take a look at the Photon Facebook user group, it's kind of amazing what people are printing in different parts of the world using these machines. They're accurate, they're reliable, because you need to think about, if you really look at some of 3D printing, the level of accuracy that we need is so low on the spectrum of 3D printing compared to what other people in different industries are trying to create with 3D printing. So that's why we've got so many options, because our 3D printing of models is not all that sophisticated as orthodontists. It's even different than people who are trying to make restorations where you're looking at margins and that type of accuracy they need. So it's fast too. I can pull things off very fast. And again, it's one of those things that you're going to, we use the same software that we use. We use that Chitubox. So we can play with the exposures, the off times, and get things as fast as we want them. We just want to make sure that it still remains reliable, that you're not increasing the risk of failure of a print job because maybe you're trying to go too fast. You don't want to underexpose things, because then actually it will make your parts smaller. If you overexpose, it tends to make parts larger. So there's a little bit of nuance, a little bit of sophistication that's required to run these cheap printers. So if you like to have fun with things like that, willing to spend a little bit of time, you can get these printers to be very accurate. So, when someone's saying an ePax isn't accurate, it's really what they're doing with it, because the technology of these smaller machines will produce a product that we need, but it's not as user-friendly. They do have a small print platform. Again, they use the same operating software that we use at Chitubox. Again, there's others out there that you can choose from. The tanks are consumable, but they're very, again, they're inexpensive as well. And there's a lot of resins that are available. So we use resins that we use on others. And my kids' school, we set them up with a couple of those, and so we've got a lot of kids that are using those. So that's something too, if you even have any kids that you want to, or staff members that want to learn to 3D print, you're afraid they're going to break the good one. You can replace parts on this if someone would break it, but a lot of times, it's not that big of an investment. So we don't use that SprintRay resin on there. You probably could. We have calibrated it for the NextDent resin. So there's some indirect bonding trays that came off of a photon. Those just have a P because we're printing the same file on all of our printers, and we're trying to keep track which is which. So that is a possibility if you're looking at even just a printer. If maybe you're just going to dabble in indirect bonding, you can print them off of photon. So, and that's what I do all of my models and aligners and my satellite off of. during the day. The one thing we found, there's what I call the mystery screws. When you're leveling that platform, you use these screws to do that, but sometimes you'll get a wobble in here. We could never figure out where it was coming from. Here, if you undo those screws completely, take it off, there's 3 mystery screws inside that a lot of people don't realize even exist. And once you tighten those up, it tightens that part back up. Because if this starts to wiggle at all, you throw the Z off and you drop print jobs. It's not accurate, and it just drove me crazy. I'm like, why won't this tighten in here? Luckily, one of the guys who was printing some Dungeons and Dragons figurines was showing the mystery screws, and I thought, aha, you just figured out what the problem was before I bought a new one of those and spent another $50 on it. Now, Photon does come with some software with it, the Photon software, which is super simple. That's why kids really like it. Again, you can dial in the exposures. This was something in a 50 micron layer, our exposure time, our off time, the bottom exposure time, and how many bottom layers we're going to have. And again, a lot of these settings exist on different, people share things on, just if you, it's amazing anymore. They were harder to find a year or 2 ago. Now they're everywhere. Manufacturers put them out, but a lot of hobbyists or dentists put things. We do have an AnyCubic Mega, which is an FDM printer that runs the spool and lays things down. We use that mainly as a demo printer where we can have that up in our clinic. I don't want the vat material, the other printers, they can give off a little bit of a smell. We're using them for production. But if we want to talk about 3D printing the kids, we can print this Selenium Falcon. We got it off of Thingiverse. Was very popular. A lot of kids wanted us to print one of those for them, or they wanted the file to print themselves. So we can do some giant teeth, things for demos, just things to be able to talk more about the technology. And obviously they were very cheap and very fun to use. Now, one thing I encourage people to do to really understand how everything is working, go ahead and do some calibration. This was a 3D printer test my son had used for a science fair project. And it's really kind of interesting. You can see when people start talking about printing horizontally, why it may and may not work on certain models. If you can't even think of these as incisal edges, different angulations, you can see how you start to lose. This is the true dimension. And then as you start to arc, see how it changes. This also shows you how far you could print without it starting to distort. So there's X, X, Y, and Z. All kind of different things to print, just to play with your printers to start to understand print orientation. We also use calibration cubes a lot. Again, this came off of Thingiverse. So you basically have a 20 millimeter cube. Print those on all your printers. If you're changing resins, you can print them. Or if you have a big print platform, print them in different parts of that platform to see how the light is dispersed throughout. That's one of the criticisms of like LED or LCD, is that the edges maybe aren't as accurate as the dead center. So print these cubes and then you can measure them. We'll measure them with a digital caliper and see the accuracy in both that X, Y, and Z. Anyhow, again, this was another one of my kids' science fair projects. They printed same on different printers, then did the measurements, and you can see some of the differences that you see. Honestly, I can't remember which printer was which, but you'd be surprised. Some of the ones that were more on were not my super expensive ones. But all of these printers will work. It depends the fit. Now, if you look at some of these numbers, these are really close, but you'd be surprised if you put it in a patient. Sometimes they can feel a difference. Some are more accurate in maybe an X or Y or more in a Z. You can really kind of determine what you want things to feel like. Here on our bigger print platform, we're printing them in different areas so we can compare. Not a lot of difference based on the area of the platform. If you print the same file over and over again and maybe stick them in your mouth or a staff member's mouth, you'll get a feel for it. Sometimes I even explain it. It's the difference if you made an appliance off of an alginate impression or a PVC impression. Because some printers, if it prints just a little bit bigger, you make a vac, it'll feel a little bit loose. Some, if it prints a little bit smaller, that's going to feel a little bit tighter. So there's a lot of different variables and you just have to decide what you like. Now, EnvisionTEC does have their own calibration file that you can print, and then SprintRay has a calibration test where you make these two pieces and you slide them, and based on what number comes up, you punch that number in, and then they'll go ahead and calibrate the machine for you. The same here. So, you know, your more sophisticated machines do a lot of it for you. Your cheaper machines, you're going to have to do it yourself. But again, it can be around with things, you know, and how small are we talking? You know, blood cells 5 microns, human hair is about 70 microns. You can't see below 50 microns. So if you have something that's printed below that, you know, once you get below 40 microns, you won't see a difference. Sometimes I see hobbyists printing stuff at like 25 microns. They like the detail they're getting, but here's the thing, under 40 microns, most people's eyes can't tell any difference. But if you blow it up real big, you can. So think about leveling. This is often overlooked, and what I think is interesting is our Formlab machine won't let you print if it's not level. And that kind of explained to me, wow, leveling must be important because a lot of your printers do not come with an automatic leveling sensor. And I really found some of my other printers, if I'd always be dropping something off the back end of a print platform. So go to the hardware store. You know, here is you have to adjust all 4 legs and get that target in the middle. If you come out a little bit, and this was a good lesson for me when I was cleaning. Moved the printers a little bit. One of them was off level. It wouldn't let me print. I had to re-level it. But what I had forgotten too was some of my other printers I had moved, and I was printing some things off of my SprintRay, and I kept dropping a model off the back left corner. You know, and sometimes if people are dropping prints off a certain part, the advice they get was rehome it. You know, make sure that that platform starts where you want it to start. But here's the thing, if it's not level, regardless of how much you home it, it's still not going to be level. So what I do is I lay my hardware store level on. If I need to adjust the legs or I have some shims behind there, once I re-leveled everything, I didn't touch anything other than sticking the shim I had behind the back of there to level it out. Because my floor's not level. Obviously, I'm in a basement. I'm sitting on some cabinets too. Everything was fine. So look at the leveling of it. I think it'll make a huge difference for people that are struggling. Now, the same thing with my EPACs is I'll level those. The thing that's a little bit more forgiving with these two as far as the level is when you home it, if you were to go ahead and home those screws, because the platforms is a little bit different, but level them all before you try to rehome it. You'll save yourself. And if you even think about the way the resin runs, luckily the one MoonRay was so unlevel when I went to pour it in, you could see all of the liquid run to one side. And I thought, oh, Lisa, you move this. It's not level. So that was really all the experience I have with those type of printers. Let's go through post-processing a little bit. Remember, when you get done, that last layer is that green layer, and you need to wash it off. So what I'm going to do is I like to use 99% isopropyl alcohol. There's other materials people are fooling with too, and we've been working on some different materials, but still this is our go-to. This was an old Formlab wash station, which I don't think they sell anymore, but you can make your own even just out of containers. You're going to put it in one area to get a lot of that uncured resin off, and then move it to the other to kind of do a final wash. One thing we found, probably about a year, maybe not quite that long ago, is that we can reclaim some of that IPA, and we just use a simple distiller. Got it off of Amazon. It's the same thing people use to make brandy and other distilled spirits, so it's a really good $100 investment, although the prices seem to have gone up since a lot of people are buying these. It is smelly when you're distilling this, so I open a door, turn on a fan. Some people have created some add-ons that will help reclaim more of it. I lose probably about 20 or 30% in the reclaiming, but there are ways that you can increase the yield, but it beats the heck out of buying new stuff all the time and then trying to get rid of the used. Now, once we've washed off the majority of the uncured resin, I'll then go ahead and put them in on an orbital shaker to shake off the rest. I found these Rubbermaid Brilliants truly are leak proof. You can flip them upside down and this stuff doesn't come out. Some of the other containers we were using tended to leak over time. They would lose the seal and it would get kind of messy and kind of splash around. Orbital shaker I just bought off Amazon. It's probably about $60, $70 just to vibrate. There's other ways. Sometimes people will even use, if they have an old stone vibrator, that will work as well if it has a big enough platform. Now, once we take that model out of this IPA, I want to blow off that alcohol. Some people will just let them bench dry, but what happens is the alcohol is evaporating, and then the that resin that was suspended in the alcohol tends to settle back down, and you'll get like a stickiness. So you want to blow off that alcohol. Since we're in our basement and we weren't plumbed, what I bought is just a simple compressor that you'd use, like, you know, for nail guns and things like that, or I use it for a pneumatic staple gun. California Air Tools, those are really pretty quiet compared to the other type that you can buy. And again, they're not very expensive. Sometimes Menards will carry them. We'll get them one. We've got one off of Amazon too, and they're probably about maybe $120, $130. As far as once you blow off that extra, you're going to cure them. You can use a cure box or a cure box plus. Formlabs has a curing system. SprintRay has a curing system. We use a cure box, and then we also have this. It's a very quick photo auto flash by EnvisionTEC when we bought our first printer. These are pretty expensive, probably around $4,500. This is around probably $500, $600 now. There's some other different options for the kids at school. I made them one out of a popcorn tin and used a $50 light from Amazon. Guess what? It works too, because you just have to look, is this the range? Because that's where, that's where a resin is cured. So there are some other options out there. I like the 20 watt. We did have a 6 watt. It didn't seem to get quite as warm. This one actually can even get a turntable if you want to get fancy. That'll spin it around too. So you've got some options there. We also have an AnyCubic cure box. This is an older style one. There's a new style they've just brought out on the market. It's kind of nice because you can wash in it. It has a little spinner in there, like a little magnetic agitator that'll help get rid of the alcohol for you. You then pull that part out and you can stick your model in, and then you can activate it as a cure box. We just created a little platform in it so that we can do multiples at the same time. So that's a good option. And I think they run about maybe $250. So that's not a bad investment as well. A lot of different options. You don't have to spend a lot. You can spend whatever you want, and you can grow by multiples. One thing we found is our regular gloves don't work very well. The resin or the IPA can still irritate some hands. So we like these nitrile gloves that are made more for construction. They're not real thick, just about maybe twice as thick of our normal gloves. They have a really nice texture to them. They're a little bit more expensive, but you know what? They're stiff enough that you can take them off and actually put them back on. So you don't have to throw them away every time. They're not as heavy as like the ones they sell for people to do dishes in. But they're not as thin as ours. So, and it's really done away with any of the hand irritation that myself or my staff were starting to experience. Shop towels work way better than paper towels. Yes, they're a little bit more expensive. Actually, there's probably better deals we buy now, just the big old roll. They go a lot longer. They really sop up the resin. So invest in some shop towels and you'll do yourself a favor. I get a lot of Dollar Tree cookie pans because when you've had uncured models, they're nice to transfer things. They're nice to set models on when you're processing them. When they get kind of gooey, they're only $1. Throw them away so you don't have to buy the expensive things. They're not really good for cookies though because they're too thin. What about storing models for your in-house aligner system? I like to share this because there's a lot of sophisticated ways to do this. But there's also an easy way and a cheap way. Again, go to your hardware store. I like our local Menards. This is a wall organizer for your garage. You can get different lengths. You're just going to mount those. Make sure at least a couple of the mounting parts are in the studs. get these tap mounts. You're supposed to hang your lawn chair on them, but actually they're really good to hang bags. And these bags just came off of Amazon. They're used in classrooms and libraries use them, and then we can just hang them as we're getting ready for production or for storage. So that's kind of, you know, cheap way. These aren't much, maybe $10, $20. Plus then you've got the mount. So we have a small one that we have upstairs in the lab when things are ready for delivery, and then we've got back more where we're storing or processing. So what about when you make a 3D printed model, when you want to make acrylic model or appliance like a retainer or something off of it? Those two materials, the acrylic you're going to want to use to make a retainer and the 3D print model, are so similar, they will chemically bond. And I'll tell you why. First tried to do it, looked like I tried to make a hockey puck, could not get them apart. You're going to need some type of separator. This Silform BEA works really well for that. It can be a little expensive. It's actually hard to find online. You have to really know what you're looking for. Once you paint a model with this, you definitely will be able to get the model free. It's one of the few that are actually approved for this type of use. There are some other ways to do it with some silicone separator that are used more in industry, but it's really not quite approved for this here. So Silform definitely works. The price can be expensive, but you know what? We bought a tub of this a while ago. I bet it's a couple years now, and we just use it. You don't use much at all. So I guess that's the message. You're not going to have to need a lot to treat your models. Now, if we're going to be making something like a vac or an aligner, I still like to coat them so they pop off easier. Certain resins, particularly those coming off of our EnvisionTEC, tend to grip onto the vac material more, and I don't want to distort it pulling off. Now, this is a food grade silicone, so it's okay to use these on models. This is like if you ever, you know, custom lollipops, different things like that. You know, you spray the inside of your mold before you pour your lollipop so it pops out. That's the same thing. So it's okay to use on a model. We don't have to worry about that. Try to use that and then put something acrylic on, because it still will stick. It's only good for vacs. Now, there's it's a problem too, soldering. You know, sometimes people will have a lab direct print metal. We can still solder, knowing that some of the resin will catch fire. So to do that, one, as my lab is soldering, they will put up an evacuation system to pull some of the air away from that solder joint. But then also too, another trick to do this is to, when you can laser weld, which we haven't invested in yet because we're, or simply use potter's clay. Get the high heat potter's clay, and then just cover the part of the model you don't want to catch fire, and this clay will absorb that heat. But make sure it's the high heat. Again, it's a huge block that we got on Amazon, so it seems to be working for us. So we haven't gone laser welding yet. Now, to help keep track of all of these things, there's a lot of programs. You maybe already have EasyRx that will help organize things. Particularly if we're going to be doing like aligners or indirect bonding, a lot of times we have just set up Smartsheet, and it's a really nice program that's used for a lot of things that are way more sophisticated than what we use it for. The nice thing is it can be seen by multiple people. It can be changed by multiple people. It continually updates, and it can be seen on different devices. So Patty may be in the lab putting some brackets on. I can see when it's done. I can jump on my computer. I can verify them, click that's approved. She's notified. So smart sheets are really, really nice if you have production that requires multiple steps and multiple people's hands in them. Some of them even, like some of the ones that are a little bit more expensive. And I think there's a free version of this, but I think we maybe buy the one that's like $100 a year or something like that to get some of these features. That this is so much easier because you can really customize it to what you want, not what's offered by the company. So that was our hard part for a while. You know, when you see a model sitting on the bench, you know you're supposed to do something with it. When it's a scan and it's sitting on your computer, You don't know that. So this way it kind of helps keep myself and about 4 or 5 of us that are printing or working on setups or working on aligner setups or fabricating those aligners to be able to keep in touch with each other, and I can pull it up even on my phone if I need to. So with all that said, and I finally got this done because I kept promising people all of this, so I hope you found it useful. It helps you make some decisions. And again, we continue to keep loading things on our channel so that we can share this information. And I think the most fun thing is you can invest a little, you can invest a lot, you can start small, grow big, you can jump in the middle. There's just so many options out there. Get online, look at other YouTube channels. Formlabs has some educational 3D print material that has to do just about 3D printing in general. I think what's hard for people is they just jump in and want to learn just how to print a model, but they don't understand the nuances of printing itself. I learned a lot from helping some of these high school kids with science fair projects, printing things that I'll never print in my life. But trying to figure out how to print a ponytail on a little Barbie doll without it failing taught me so much about undercuts and incisal edges that I never really would have thought of. So have a lot of fun. Obviously, you can reach out to me, and this is my experience as today, and it keeps changing. So thanks.